Thevenin's theorem. First of all, we will see the statement of Thevenin's theorem. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit. Now, what is linear two-terminal circuit? Suppose if the circuit contains all the resistor. Now, resistor is the linear component. So, if the circuit contains all the linear elements, then that circuit is called as linear circuit. So, it can be replaced by an equivalent circuit consisting of a voltage source VTH. Now, this is the Thevenin equivalent circuit. It consists of voltage source VTH. This is Thevenin voltage in series with a resistor RTH. Now, here we can see this voltage source is in series with resistor RTH. So, this is called as Thevenin resistance RTH, where VTH is the open circuit voltage at the terminals. Now, this VTH is the open circuit voltage. Now, what is mean by open circuit voltage? If we remove the load resistor RL from the circuit, then that voltage is called as open circuit voltage at the terminals, and RTH is the equivalent resistance. Now, this RTH, that is Thevenin resistance, is the equivalent resistance at the terminals when the independent sources are turned off. When we turn off independent sources, there are two types of independent sources. One is independent voltage source and second is independent current source. Now, when we turn off independent sources, that time we have to replace it by its equivalent resistance. So, when we turn off independent voltage source, that time we have to replace it by its equivalent resistance. That means we have to replace it by a short circuit. And when we turn off a current source, that time we have to replace it by its open circuit. So, remember that for voltage source we have to short circuit the terminals, and for current source we have to open circuit the terminals. Now, this Thevenin voltage and Thevenin resistance, these are connected in series. Now, in series with these two, we have to also connect load resistor RL, and the current through this load resistor RL is IL. This IL is called as load current. Now, if we want to find this load current IL, then the formula is IL is equal to VTH upon RTH plus RL. This is simple Ohm's law. We know that according to Ohm's law, current is equal to voltage upon resistance. So, here the current is load current IL and the voltage is VTH and the resistance. Now, here we have to take both the resistance. These two resistance are connected in series. So, when the resistances are connected in series, that time we have to add them. So, it will be RTH plus RL. So, this is the formula for finding load current IL, and this is called as Thevenin equivalent circuit. Question: find I using Thevenin's theorem. Here in this circuit, we have to find the value of this current I by using Thevenin's theorem. Solution: so to find the solution by using Thevenin's theorem, first of all we will find RTH. So, to find RTH, that is Thevenin resistance, remove RL and turn off all independent sources. Now, here in this circuit, we have to find this current I. That means this will be our load resistor. So this is load resistor. And now these two terminal will be RTH. Turn off all independent sources. So here we can see in this circuit there are two independent sources. So when we turn off a voltage source, that time we have to replace it by short circuit. So let's replace this by short circuit. Again there is one more voltage source. So we have to replace this by its equivalent resistance, that is short circuit. Now here we can see if we stretch this terminal and this terminal, then this 6 ohm and this 6 ohm are connected in parallel. So therefore RTH is equal to 6 ohm parallel with 6 ohm. So therefore RTH is equal to 6 into 6 divided by 6 plus 6. So therefore RTH is equal to 3 ohm. Next we have to find the value of VTH. So step number 2, to find VTH, remove RL and find open circuit voltage. Open circuit voltage. Now again to find this VTH, we have to remove this load resistor. Now let's say again this is terminal A, let's say, and this is terminal B. This is positive and this is negative. So we have to find this voltage. Now this voltage is open circuit voltage, or it is called as Thevenin's voltage, VTH. Now to find this voltage, first we have to find this current, the current through this circuit. So to find current through this circuit, we will apply Kirchhoff's voltage law. So let's apply KVL to the outer loop. Apply KVL to outer loop. And let's say this current is current IT, let's say. Now here we are starting from this point, let's say, so it is minus 24, then this will be plus, this will be minus, this will be plus, this will be minus, according to the direction of this current. We are assuming this direction, so minus 24, then plus 6 into IT, then plus 6 into IT, then plus 12. Now here the loop is completed, so it is equal to 0. Now let's solve this. So here minus 24 and 12, this will be minus 12, and this 6 IT plus 6 IT, this will be plus 12 IT is equal to 0. If we take this 12 on right side, so it will be 12 IT is equal to 12. So IT is equal to 12 upon 12, which is equal to 1 ampere. Now we got this outer current. Now we have to find this current. Now let's say this current is current I1. Let's say this is current I1 and this is mesh number 1. This is loop number 1 or mesh number 1. Now we will apply KVL to loop 1. Now here we can see this is the loop 1. Let's say again we are starting from this minus 24. So minus 24. Then plus 6. Now here this IT and this I1 will be same because the current through this 6 ohm will be same. So this IT is equal to I1. So first we will write I1, then we will write IT value. So this will be minus 24, then plus 6 I1 plus 6 I1, then plus VTH plus VTH is equal to 0. Now this will be minus 24 plus 6 into I1. Now this I1 is equal to, since I1 is equal to IT. So I1 is equal to IT and the value of IT is 1 ampere. So it will be 1 plus VTH is equal to 0. Now if we take this on right side, so it will be 6 into 1, 6 plus VTH is equal to 24 and this VTH is equal to 24 minus 6. So therefore VTH is equal to, now 24 minus 6. So this will be 18 volt. Now we got the value of VTH and RTH. And we also have the value of load resistor RL. So we can easily draw Thevenin equivalent circuit. So let's draw Thevenin equivalent circuit. This is plus, minus. This is load resistor RL, this is RTH and this is VTH. VTH is equal to 18 volt, RTH is equal to 3 ohm. So 3 ohm. And now what is RL? So here we can see we have to find the current through this 6 ohm. That means this is our load resistor. So RL is equal to 6 ohm. RL is equal to 6 ohm. And this current is current IL. And the formula to calculate IL is equal to VTH upon RTH plus RL. This is the formula for finding this current IL. Now let's put all the values. So VTH is 18, RTH is 3 ohm plus RL is 6 ohm. So if we calculate this, we get IL is equal to 18 upon 3 plus 6. So it is 2 ampere. That means the value of this current I is 2 ampere. So therefore I is equal to 2 ampere. And also remember that this circuit is called as Thevenin's equivalent circuit. Question: find the Thevenin's equivalent circuit for the following circuit. Here for this circuit we have to find its Thevenin equivalent circuit. Solution. Here the value of load resistor RL is absent. So we have to find the value of RTH. So step number 1 is to find RTH. To find RTH, what we do generally, we remove the RL, remove RL. Now here the RL or load resistor is already absent. So remove RL and turn off all independent sources. So when we turn off independent sources, when we turn off a voltage source, that time we have to replace it by its short circuit. And when we turn off a current source, independent current source, that time we have to replace it by open circuit. Now here this will be our Thevenin's resistance RTH. Now here we can clearly see this 5 ohm and 20 ohm, these are connected in parallel and it is in series with 4 ohm. So therefore RTH, Thevenin's resistance, is equal to this 4 ohm plus 5 ohm parallel with 5 ohm parallel with 20 ohm. So 4 plus 5 into 20 divided by 5 plus 20. If we solve this, then we get RTH is equal to 4 plus 5 into 20 divided by 5 plus 20. So it is 8 ohm. Now we got the value of RTH. Next we have to find the value of VTH, Thevenin's voltage. To find VTH, again what we will do, remove RL and VTH is equal to VOC, that is open circuit voltage is equal to VTH. So here is the circuit. Now here the RL is already absent and this is the open circuit voltage. Now this will be our VTH. Now we have to find this voltage. Now here the voltage across this 3 ampere will be VTH. So here, or this is one combined node. So this will be our VTH. So let's find the value of VTH. What we will do, we will use Kirchhoff's current law. Let's assume this is a reference node or ground node and let's say this is current I1, this is current I2. Now let's apply KCL at node VTH. Apply KCL at node VTH. So according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node, entering current R, I1 is the entering current and this 3 ampere is the entering current. So I1 plus 3 is equal to I1 plus 3 is equal to I2. Now this I1 can be written as 25 minus VTH divided by 5. 25 minus VTH divided by 5. So this is the simple Ohm's law. According to Ohm's law, current is equal to voltage upon resistance. So this is the voltage and this is the resistance. Plus 3 is equal to I2. Now I2 is VTH. This VTH minus 0 divided by 20. VTH minus 0 divided by 20. So it will be 25 divided by 5. 25 divided by 5 minus VTH divided by 5. Then plus 3. If we take this on left side, so it will be minus VTH divided by 20 is equal to 0. So 25 divided by 5 minus VTH divided by 5 plus 3, then minus VTH by 20. So let's take VTH common first. If we take VTH common, then minus 1 by 5 and this will be minus 1 by 20 and this will be 5. So plus 5 plus 3 is equal to 0. So VTH, now if we solve this, we get minus 1 by 5 minus 1 by 20. So it is minus 0.25 plus 8 is equal to 0. So VTH is equal to VTH into minus 0.25 is equal to minus 8. And if we take this on this side, so it will be in division. But before that, this minus and this minus will get cancelled. So VTH is equal to 8 divided by 0.25. So therefore, VTH is equal to 8 divided by 0.25. So it is 32. 32 volt is the value of VTH. Now we got the value of VTH and we also got the value of RTH. Now what we can do? We can draw the Thevenin's equivalent circuit. So now this will be our VTH. This is VTH. This is RTH. And here this will be load resistor RL, which is absent here. So this will be terminal A and this will be terminal B. So VTH is equal to 32 volt and RTH is equal to 8 ohm. 8 ohm. And this will be load resistor RL, which is absent here. What we have to find in this problem? We have to find the Thevenin's equivalent circuit for the following circuit. So this is the Thevenin's equivalent circuit. If you want notes, then check the link in the description below and install the app now. Question: find IL for the circuit shown in figure using Thevenin's theorem. Here for this circuit, we have to find the value of this IL by using Thevenin's theorem. Solution: first of all, we will take this circuit from here. Now, step number 1 is to find the value of RTH. So to find RTH, that is Thevenin's resistance, remove RL and turn off all independent sources. All independent sources. Now here we can see RL, load resistor value is 30 ohm. Because we have to find this current IL, that means this 30 ohm will be the load resistor. So let's remove this RL from here. Now this will be our RTH. These two terminal, between these two terminal, this will be RTH, that is Thevenin's resistance. And now we have to turn off all the independent sources. So as we can see, this is an independent voltage source. So when we turn off independent voltage source, that time it will be replaced by a short circuit. Again, there is one more independent voltage source. So when we turn off independent voltage source, that time it will be replaced by a short circuit. Now if we stretch this terminal this side and this terminal this side, so we can see that this 10 ohm and this 20 ohm are connected in parallel. So here we can write RTH is equal to 10 ohm parallel with 20 ohm. So RTH is equal to 10 into 20 divided by 10 plus 20. So RTH is equal to 10 into 20 divided by 10 plus 20. So it is equal to 20 by 3. 20 by 3 ohm. This is the value of RTH. Next we have to find the value of VTH, that is Thevenin's voltage. So to find VTH, again remove RL. Let's take this circuit from here again. Now we will remove this load resistor RL, and this open circuit voltage will be VTH. So we have to find this VTH. First of all, let's find this current. Let's say this is current capital I. So to find this current capital I, we will apply KVL to outer loop. Apply KVL to outer loop. Then we get, let's say we are starting from this point. So it will be minus 50. So minus 50. Then this 10 ohm and this 20 ohm are connected in series. So it will be plus 30 into current I. Then plus 20 is equal to 0. Now we can easily find the value of current I. As we can see, this minus 50 and plus 20. So this will be minus 30 plus 30I is equal to 0. So 30I is equal to 30. So therefore I is equal to 30 divided by 30, which is equal to, I is equal to 1 ampere. Now we got the value of I. So here in this loop, let's say this is loop number 1 with current I1. So apply. Now we will apply KVL to loop 1. This is positive and this is negative. Let's say again we are starting from this point, so it will be minus 50. Then this will be plus, this will be minus. So minus 50, then plus 10 into this current. Now this current I and this current I1 will be same because it is the same resistor. So plus 10I1 plus 10I1 plus VTH is equal to 0 plus VTH is equal to 0. Now this I1 is equal to 1 ampere. Here we can write is equal to I1. So minus 50, then plus 10 into 1, then plus VTH is equal to 0. So now minus 50 plus 10, this will be minus 40 plus VTH is equal to 0. So VTH is equal to 40 volt. Now we got the value of VTH and we also got the value of RTH. Now we can draw Thevenin equivalent circuit. So here this is VTH, Thevenin's voltage. It is in series with resistor RTH. So this is RTH and this is load resistor RL. This is load resistor RL, this is RTH and this is VTH. So VTH is equal to 40 volt, RTH is equal to, here we can see RTH is equal to 20 by 3 ohm. So here we can write 20 by 3 ohm and the value of RL value is 30 ohm. So 30 ohm and we have to find this current IL. Now this circuit is called as Thevenin equivalent circuit. Thevenin's equivalent circuit. And the formula to calculate IL is equal to VTH upon RTH plus RL. Now here the value of VTH is 40, RTH value is 20 by 3 plus RL value is 30. So therefore IL is equal to, let's calculate this. So it will be 40 divided by 20 by 3 plus 30. It is 1.09. 1.09 ampere is the value of load current IL. In this video, we will see a problem on Thevenin's theorem. Question: find IL through RL using Thevenin's theorem. Here for this circuit, we have to find the value of this IL by using Thevenin's theorem. Solution: first step is to find the value of RTH. So to find RTH, that is Thevenin's resistance, what we have to do? We have to remove RL and turn off all independent sources. Turn off all independent sources and remove RL. So here this is the circuit. Now what we have to do? We have to remove this RL. So let's remove this RL. Now let's say this terminal is terminal A and this terminal is terminal B. Now the resistance between these two terminals will be RTH, that is Thevenin's resistance. And next what we have to do? We have to turn off all independent sources. So here this 12 volt is an independent voltage source. Now when we turn off an independent voltage source, that time we have to replace it by a short circuit. Now we can easily find the value of RTH. Now here we can see this 3 ohm and 6 ohm are connected in parallel. So 3 ohm parallel with 6 ohm. So if we solve this, it will be 3 into 6 divided by 3 plus 6. So let's put this in calculator. 3 into 6 divided by 3 plus 6. So it is 2 ohm. Now let's copy this circuit. Now we can replace this 3 ohm and 6 ohm by a single resistor of 2 ohm. So this resistance will be of 2 ohm now. Now we can see 2 ohm, 3 ohm and 5 ohm. These are connected in series. So let's solve this. So 5 plus 2 plus 3. So 5 plus 2, 7. 7 plus 3, 10. So this will be of 10 ohm. Again, let's copy this circuit. Now we can replace this 3 resistance by a single resistance of 10 ohm. So this will be of 10 ohm. Now here we can see this 10 ohm and 10 ohm are connected in parallel. So 10 ohm parallel with 10 ohm. Now their values are equal. So their equivalent resistance will be half of it. So let's solve it in a conventional way. So 10 into 10 divided by 10 plus 10. So this will be equal to 5 ohm. Again we can replace these two resistances by a single resistance of 5 ohm. So let's replace 10 ohm parallel with 10 ohm by a single resistance of 5 ohm. Now here this will be of 5 ohm. Now this 7 ohm and 5 ohm are connected in series. So therefore RTH is equal to 5 plus 7. So therefore RTH is equal to 12 ohm. Now we got the value of RTH. Next we have to find the value of Thevenin's voltage VTH. So to find VTH, again what we have to do, we have to remove RL and find VOC is equal to VTH. Now VOC is the open circuit voltage. So again let's copy this circuit from here. Now this time we will remove this RL and this will be our VTH. This will be positive and this will be negative here. Now here we can see this 7 ohm is open circuited, so there will be no current. So that's why this voltage will be our VTH. Now to find this voltage VTH, it is the voltage across this 10 ohm and this 5 ohm. These are connected in series. So let's find this voltage. So before that we have to find its total current. So let's say this current is IT. So let's find total current. Again let's copy this circuit and simplify it to better understand this. So let's erase all of this to make it simpler. Now here we can clearly see this 3 ohm, 10 ohm and this 5 ohm, these are connected in series. So it will be 3 plus 10 plus 5. 3 plus 10, 13, 13 plus 5, 18. So it is of 18 ohm. So let's replace this by a single resistance of 18 ohm. it will be of 18 ohm. Now this 6 ohm and 18 ohm are connected in parallel. 6 ohm parallel with 18 ohm. So it will be 6 into 18 divided by 6 plus 18. If we solve this, we get 6 into 18 divided by 6 plus 18. So it is 4.5. Again, let's take this circuit. Now we can replace these two resistances by a single resistance of 4.5. So this will be of 4.5 ohm. Now we can easily find the value of IT. So IT is equal to V upon R. Now here the value of V is 12 and the value of resistance will be 3 plus 4.5. So therefore IT is equal to 12 divided by 3 plus 4.5. 12 divided by 3 plus 4.5. So it is equal to 1.6. 1.6 ampere is the value of IT. But here we have to find the value of VTH. Now let's say this current is current I1. Again, let's copy this circuit from here. Now we have the value of IT. But we have to find the value of this VTH. So to find VTH, we need the value of I1. So by using current division rule, we can find the value of I1. I1 is equal to this current IT multiplied with opposite branch resistance. Now opposite branch or parallel branch to this branch is 6 ohm. So 6 divided by 6 plus, now we have to take addition of all of this, 3 plus 10 plus 5. So 3 plus 10, 13, 13 plus 5, 18. So therefore I1 is equal to, now the value of IT is 1.6. 1.6 into 6 divided by 6 plus 18. So therefore I1 is equal to, let's solve this, 1.6 into 6 divided by 6 plus 18. So it is 0.4. Now 0.4 ampere. Now we can easily find the value of VTH. VTH is the voltage across. It is the voltage across this 10 ohm. And this current is current I1. So here we can find VTH. So VTH is equal to this resistance 10 ohm multiplied with I1. So 10 into I1 value is 0.4. So therefore VTH is equal to 4 volt. If we multiply 10 into 0.4, it will be of 4 volt. Now we got the value of VTH and we have also found the value of RTH. So we can draw Thevenin equivalent circuit. Now in Thevenin equivalent circuit, we need a voltage source VTH. This is VTH and it is in series with RTH. So this is RTH and there will be a load resistor RL. This is load resistor RL and load current IL. And this is called as Thevenin's equivalent circuit. Now let's put the value of VTH. It is equal to 4 volt. The value of RTH is 12 ohm. So this will be of 12 ohm and the value of RL. The value of RL is, here we can see the value of RL is 8 ohm. This is the value of RL, 8 ohm. So 8 ohm. Now the formula to calculate IL is equal to VTH upon RTH plus RL. So the value of VTH is 4 volt and the value of RTH is 12 and the value of RL is 8. If we solve this, we get the value of IL. Let's solve this. 4 divided by 12 plus 8. So it is 0.2 ampere. Now what we have to find in this problem? We have to find IL by using Thevenin's theorem. So here this is the value of IL. Don't forget to like, share and subscribe to this channel, and also install the app from the link in the description below. If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see a problem on Thevenin's theorem. Question: find VO using Thevenin's theorem. Now here for this circuit, we have to find the value of VO. Now this VO is the voltage across this 8 ohm resistance. Solution: so first of all, we have to find the value of RTH. So step number 1 is to find RTH. Now to find RTH, remove RL and turn off all independent sources. All independent sources. Now here in this circuit, this is the load resistor RL. Here we can write RL is equal to 8 ohm. So let's remove this RL. Now here this will be our Thevenin's resistance RTH, and we have to turn off all the independent sources. Now here this current source is an independent current source, so when we turn off independent current source, that time we have to replace it by open circuit. So let's replace this by open circuit, and when we turn off a voltage source, independent voltage source, that time we have to replace it by short circuit. Now we can easily find the value of RTH. Here we can see 3 ohm and 6 ohm are connected in parallel. So 3 ohm parallel with 6 ohm. This will be 3 into 6 divided by 3 plus 6. So it is equal to 3 into 6 divided by 3 plus 6. It is 2. So this is 2 ohm. Now let's copy this circuit, and we can replace these two resistors by a single resistance of 2 ohm. So this will be of 2 ohm. Now here we can see RTH is equal to, these are all the resistances connected in series. So it will be 4 plus 2 plus 2. 4 plus 2 plus 2. Which is equal to 4 plus 2 6, 6 plus 2 8. So therefore RTH is equal to 8 ohm. Now we got the value of RTH. Next we have to find the value of VTH. To find VTH, that is Thevenin's voltage, again what we have to do, we have to remove RL, and VOC is equal to VTH. That means we have to find open circuit voltage, which will be equal to Thevenin's voltage. So let's take this circuit from here again. Let's copy this. Now let's remove RL first. So here this 8 ohm is the value of RL. And now this will be our VTH. This is positive and this is negative. Now here this 4 ohm is open circuited. That means this node voltage will be our VTH. The voltage across this current source will be VTH. So here we can use mesh analysis to find the value of VTH, or we can use nodal analysis to find the value of VTH. So let's use nodal analysis. Let's say this is a reference node or ground node. Let's say this is node V1 and this is node VTH. We have to assume all the currents towards this reference node. So let's say this is current I1, this is current I2, and this is current. Now here this 2 ohm is in series with 2 ampere. So this current will be 2 ampere. Now let's apply KCL at node V1. Apply KCL at node V1. Now according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node entering current is I1. So I1 is the entering current and this 2 ampere is also entering. So I1 plus 2 is equal to leaving current is I2. Now we can write I1 as 12 minus V1. 12 minus V1 divided by 3. Then plus 2 is equal to I2. Now this I2 is V1 minus 0 divided by 6. V1 minus 0 divided by 6. Now we can easily find the value of V1 from this. So let's find V1. So simplifying this. So 12 by 3 minus V1 divided by 3 plus 2. Now if we take this on left side, so it will be minus V1 by 6 is equal to 0. We can take V1 common. So V1 in bracket minus 1 by 3 minus 1 by 6. And this will be 4. 4 plus 2. So 4 plus 2 is 6 is equal to 0. So V1 in bracket, let's solve this. It will be minus 1 by 3 minus 1 by 6. So it is minus 1 by 2 or minus 0.5. Minus 0.5 plus 6 is equal to 0. So V1 in bracket minus 0.5 is equal to minus 6. So V1 is equal to this minus and this minus will get cancelled. So 6 divided by 0.5. So V1 is equal to 6 divided by 0.5, which is equal to 12 volt. Now since we got the value of V1, but here we have to find the value of VTH. Now this VTH will be, now here VTH minus V1 is equal to 2 ampere. VTH minus V1 divided by VTH minus V1 divided by 2 ohm is equal to 2 ampere. Here we can see VTH minus V1 divided by 2 is equal to 2 ampere. Now we got the value of V1. So V1 is 12. So VTH minus 12 divided by 2 is equal to 2. We can take this 2 on this side. So it will be VTH minus 12 is equal to 4. We can take this on right side. So VTH is equal to 4 plus 12. Now VTH is equal to 16 volt. Now we got the value of VTH and we also got the value of RTH. So now we can draw Thevenin equivalent circuit. So this is VTH. This is VTH. This is RTH. RTH. And this is load resistor RL. This is RL. The value of VTH is 16 volt. The value of RTH value is 8 ohm. And the value of RL. The value of RL is also 8 ohm. RL is equal to 8 ohm. Now what we have to find? We have to find voltage across this 8 ohm, which is VO. So the voltage across this 8 ohm is VO. Now this circuit is called as Thevenin's equivalent circuit. Thevenin's equivalent circuit. And this current is current IL. Now to find the value of IL, there is a formula. IL is equal to VTH divided by RTH plus RL. This is simple Ohm's law. Voltage divided by resistance. So the value of VTH is 16 divided by RTH value is 8 plus RL value is also 8. So 16 divided by RTH is 8 and RL is also 8. So 16 by 16 is 1 ampere. So this is the value for IL, but here we have to find the value of VO. Now VO is equal to this RL into IL. We have to multiply current and resistance to get the value of voltage. So RL into IL. So VO is equal to RL value is 8 ohm and IL value is 1 ampere. So therefore VO is equal to 8 volt. Don't forget to check out the other videos on this channel and thanks for watching. In this video we will see a problem on Thevenin's theorem. But before that, if you want more practice problems and notes, then check the link in the description below and install the app now. Also, check out the other videos on this channel. Question: determine IAB by applying Thevenin's theorem. Now here in this circuit, we have to find the value of IAB by using Thevenin's theorem. Solution: step number 1 is to find the value of RTH. So to find RTH, remove RL and turn off all independent sources. Now here in this circuit, we have to remove this RL. Now remember that we have to find this current IAB. That means our load resistor will be 8 ohm. So let's remove this RL. And now this will be our RTH. Then next step is to turn off all the independent sources. Now here this voltage source will be turned off, and when we turn off a voltage source, that time we have to replace it by a short circuit. And when we turn off a current source, that time we have to replace it by open circuit. So now this is the circuit we got. But here we can see this 6 ohm and 4 ohm are open circuited. So again we can redraw this. And we can remove this we can remove these two resistors. Now we can easily find the value of RTH. So RTH is equal to 6 ohm is in series with 4 ohm. So it will be 6 plus 4. So therefore RTH is equal to 10 ohm. Now next we have to find the value of VTH, that is Thevenin's voltage. This is Thevenin's resistance. Next is to find VTH. Again remove RL and VOC is equal to VTH. Now what is VOC? VOC is the open circuit voltage. So let's copy this circuit from here. Now we will remove this load resistor first. And now this will be our VTH. And here this will be positive, this will be negative. Now we have to find the value of VTH. Now here we can see this 20 ampere is in series with this voltage source. That means the current through this circuit will be of 20 ampere. Remember that when current source is in series with voltage source, that time we have to take 20 ampere or current source value as the series current. Now here we can apply KVL. Let's say this is loop number 1. Now we will apply KVL to loop number 1. Now according to the direction of this current, this will be positive, this will be negative, this will be positive and this will be negative. Let's say we are starting from this point. So it will be plus VTH, then plus 4 into 20, then plus 50, then plus 6 into 20 is equal to 0. Now VTH, now let's solve this. So it will be 4 into 20 plus 50 plus 6 into 20. It is equal to 250. So plus 250 is equal to 0. So therefore VTH is equal to minus 250 volt. Now we got the value of VTH and we also got the value of RTH. So we can draw Thevenin equivalent circuit. So for Thevenin equivalent circuit, we need a voltage source VTH. So this is VTH in series with resistor RTH. That is Thevenin's resistance RTH and a load resistor RL. The value of VTH is minus 250 volt and the value of RTH is 10 ohm and the value of RL is 8 ohm and we have to find this current IL. The formula to calculate IL is VTH upon RTH plus RL. The value of VTH is minus 250 divided by RTH value is 10 plus RL value is 8. So if we solve this, we get IL is equal to, let's solve this in calculator, minus 250 divided by 10 plus 8. So it is minus 13.8 ampere. Now since we have to find IAB, that is the direction of current is upward. So it will be like this, IAB. So here IL is equal to minus IAB. So it is equal to minus, here we can write IL is equal to minus IAB, and the value of IL is minus 13.8 is equal to minus IAB. So therefore IAB is equal to minus 13.8 ampere, not minus 13.8. This minus and this minus will get cancelled. So only 13.8 ampere. Don't forget to check out the other videos on this channel and install the app from the link in the description below. And thanks for watching. If you want to buy notes, then check the link in the comment section and install the app now. Also, at the end of this video, we will see the simulator answer and we will verify our answer by using circuit simulator. Question: find the current in branch AB of the circuit shown in figure using Thevenin's theorem. Here for this circuit, we have to find the value of this current, the current through this branch. That means we have to find the current through this 10 ohm resistance by using Thevenin's theorem. Solution: first of all, here we know that the value of RL, here we can write RL is equal to 10 ohm. Now we need the value of RTH, that is Thevenin's resistance, and also we need the value of VTH, which is the Thevenin's voltage. Then from this we can draw the Thevenin equivalent circuit. So first of all, let's find the value of RTH. So to find RTH, what we will do? We will remove RL. Remove RL and turn off all independent sources. Independent sources. So here let's remove RL. So here this is our RL. Now this will be removed from here, and now this will be our RTH. And also we have to turn off all the independent sources. So here when we turn off this voltage source, that time it will be replaced by a short circuit. Again when we turn off this voltage source, so it will be replaced by a short circuit. When we turn off or replace the voltage source, that time we have to replace it by short circuit. And when we remove or replace a current source, that time we have to replace it by open circuit. Now here we can see this 15 ohm and this 5 ohm are connected in parallel. So here we can write 15 ohm parallel with 5 ohm. If we solve this, we get 15 into 5 divided by 15 plus 5. 15 into 5 divided by 15 plus 5. So it is 3.75 ohm. Now here we can see this 8 ohm and 8 ohm are connected in parallel. So 8 ohm parallel with 8 ohm. This will be 8 into 8 divided by 8 plus 8. If we solve this, we get 4 ohm directly. So again we can redraw this circuit. Let's copy this circuit from here. Now we can replace these resistance by a single resistance of, we can replace 5 ohm and 15 ohm by 3.75 ohm. It will be 3.75 ohm. And we can replace these two 8 ohm resistance by a single resistance of 4 ohm. So let's replace this by 4 ohm. It will be of 4 ohm. Now here we can clearly see this 3.75 ohm is in series with 4 ohm. So we can write RTH is equal to 3.75 plus 4. So it will be 7.75 ohm. Now we got the value of Thevenin's resistance RTH. Now next step is to find the value of VTH. So step number 2 is to find VTH. To find VTH, what we will do, we will remove RL and find VOC is equal to VTH. Now this VOC is the open circuit voltage at the terminals when all the independent sources. This VTH is the open circuit voltage simply. So let's find the value of VTH. So let's remove this RL first. Now here this will be our VTH. This is VTH, this is positive, this is negative. Now we can easily find the value of VTH. Let's say this is loop number 1 with current I1 and this is loop number 2 with current I2. Now we have to find voltage across this 5 ohm and voltage across this 8 ohm. That means VTH is equal to VA minus VB. Now this VA is the voltage across this 5 ohm and VB is the voltage across 8 ohm. So here the positive terminal of this VTH is on this side and negative terminal is on this side. So VA minus VB is equal to VTH. So let's find the value of VA. So to find VA, we need the value of I1 first. So I1 is equal to V upon R. So here the value of voltage is 6 volt and the value of resistance is 15 plus 5. 15 plus 5, it will be 6 divided by 15 plus 5. It is 0.3 ampere. So therefore voltage across this 5 ohm will be VA is equal to V5 ohm is equal to 5 into 5 multiplied with 0.3. What we have to do? We have to multiply I1 with this resistance value. Then we get the value of voltage value. The voltage across this 5 ohm. So it will be 5 into 0.3. It is 1.5 volt. Then next, similarly we will do this for I2. So first we will find the value of I2. So I2 is equal to V by R. So voltage value here is 6 volt and resistance value is 8 plus 8. We have to take total resistance. So 8 plus 8. It is equal to 6 divided by 8 plus 8. Now it is equal to 0.375 ampere. Also remember that the direction of current is from positive terminal of battery to negative terminal of battery. Here also from positive to negative. This is the direction of current. Now let's find the value of this VB. VB is the voltage across 8 ohm resistance. So it will be I2 multiplied with 8 ohm. So I2 value is 0.375 into 8. So let's multiply it 0.375 into 8. It is equal to 3 volt. Now we got the value of VA and we got the value of VB. So therefore VTH is equal to VA minus VB. VA value is 1.5 minus VB value is 3. So 1.5 minus 3. It is equal to minus 1.5. So minus 1.5 volt is the value of VTH. Now next we got the value of VTH minus 1.5 volt. We also got the value of RTH and we also have the value of RL. Here we can see we have the value of RL and we have the value of RTH also and we also have the value of VTH. So from this we can draw Thevenin equivalent circuit. So let's draw Thevenin equivalent circuit. Here this will be our VTH. This is VTH. This is RTH. And this is RL. This is terminal A. This is terminal B. This is RL. This is RTH. And this is VTH. And this circuit is called as Thevenin's equivalent circuit. What is the value of VTH? It is minus 1.5 volt. What is the value of RTH? RTH value is 7.75 ohm. 7.75 ohm. And what is the value of RL? Now here we can see the value of RL is 10 ohm. Now we have to find this current, and this current is IL. The formula to calculate IL is equal to VTH upon RTH plus RL. The value of VTH is minus 1.5. The value of RTH is 7.75 and the value of RL is 10. So therefore IL is equal to minus 1.5 divided by 7.75 plus 10. So it is equal to minus 0.084. Minus 0.084 ampere. Or we can also write IL is equal to minus 84.5 milliampere, because here it is multiplied with 10 to the power minus 3. So we can replace this 10 to the power minus 3 by milliampere. Now what we have to find in this problem? We have to find the current through this 10 ohm by using Thevenin's theorem. Now let's verify our answer by using circuit simulator. Now as we can see, this is the circuit simulator, and here the current through this 10 ohm is 84.5 milliampere, and also we can see the direction of current is from right to left. So hence our answer is correct. Don't forget to like, share and subscribe to this channel, and thanks for watching. In this video we will see a problem on Thevenin's theorem. If you want to buy my notes, then check the link in the description below and install the app now. Also, don't forget to like, share and subscribe to this channel. Question: find the current through 6 ohm resistor for the circuit shown in figure using Thevenin's theorem. Here for this circuit, we have to find the value of current through this 6 ohm resistor by using Thevenin's theorem. Solution: so for Thevenin's theorem, we need the value of RL, RTH and VTH. Now here in this circuit, we have the value of load resistor RL and it is 6 ohm. The value of RTH is unknown and the value of VTH is unknown. So first of all, let's find the value of RTH. So to find RTH, what we will do? Turn off, remove RL first, remove RL and turn off all independent sources. Now here in this circuit, if we remove RL and when we turn off all the independent sources, then this will be our RTH. Now here we can see, when we turn off this voltage source, that time it will be replaced by short circuit. Again, when we turn off this voltage source, it will be replaced by short circuit, because voltage source, independent voltage source replaced by short circuit, and independent current sources are replaced by open circuit. Now here we can see this 4 ohm and 5 ohm are connected in series. So their equivalent resistance will be 4 plus 5, 9 ohm. So it will be 9 ohm. Now this 9 ohm and this 10 ohm are connected in parallel. Here we can write 9 ohm parallel with 10 ohm. It will be 9 into 10 divided by 9 plus 10. If we solve this, we get 9 into 10 divided by 9 plus 10. It is equal to 4.73. 4.73 ohm is the value of RTH. It is the resistance between terminal A and terminal B, 4.73. Now similarly, we will find the value of VTH. So to find VTH, what we will do? We will remove RL and find VOC is equal to VTH. That is, VOC is the open circuit voltage at the terminals. Now here, if we remove this RL, this will be our VTH now. This will be positive, this will be negative. And this is VTH. So here we can see VTH is equal to VA minus VB, or simply we can apply, first we will apply KVL to this loop, or first of all we will find this current. Then we will apply KVL to this loop. Let's say this is loop number 1 with current I1, let's say. So we need the value of this current also, the current through this 10 ohm resistance, to apply KVL in loop number 1. So let's find this current first. So let's say this current is current I. Now according to the direction of this current direction will be like this, because positive terminal is here. So from positive to negative, it will be like this. Now according to the direction of this current, this will be positive, negative, positive, negative, positive, negative. So let's apply KVL. Let's say we are starting from this point. So it will be minus 10. Here we can write apply KVL to right side loop. Let's say we are starting from this point, so it will be minus 10, then plus 5 I1 plus 5 I, then plus 4 I, then plus 10 I is equal to 0. Now let's simplify this. So it will be minus 10, 5 plus 4, 9, 9 plus 10, 19. So it will be plus 19I is equal to 0. So 19I is equal to 10. If we take this on right side, it will be plus. So therefore I is equal to 10 divided by 19. So I is equal to 10 divided by 19. It is, or we can put 10 by 19 as it is to get the precise answer. So let's put 10 by 19 ampere as it is. Now let's apply KVL on left side. Apply KVL to loop 1. Let's say we are starting from this point, let's say. So according to the direction of this current, it will be positive and negative here. So from here it will be minus 18, then plus VTH, then plus 10 into current. Now here this I1 will be equal to current I. So we can write I1 and here we can write I1 is equal to I. So then 10 into I1, then minus 10, then is equal to 0. So let's simplify this. Minus 18 and minus 10, this will be minus 28 plus VTH plus 10 into I1. Now 10 into I1 is 10 by 19. 10 by 19 is equal to 0. Now here we can take this on right side, so it will be VTH is equal to, it will be 28 and this will be minus 100, 10 into 10, 100 divided by 19. So therefore VTH is equal to 28 minus 100 divided by 19. So it is 22.73 volt. Now we got the value of VTH also, and we also got the value of RTH. Now what we will do? We will make the Thevenin equivalent circuit. So this is VTH and then this is RTH. VTH this is RTH. VTH is in series with RTH and it is in series with RL. This is RL. Now VTH value is 22.73 volt. The value of RTH value is 4.73 ohm. Then the value of RL value is 6 ohm. Now here this is the value of RTH, this is the value of RL, and this is the value of VTH, and we have to find this current IL. So IL is equal to VTH upon RTH plus RL. This is the simple Ohm's law. Current is equal to voltage divided by resistance. So VTH value is 22.73 divided by RTH value is 4.73 plus RL value is 6 ohm. If we solve this, we get IL is equal to 22.73 divided by 4.73 plus 6. Now it is equal to 2.118 ampere is the value for load resistor IL. That means the current through 6 ohm resistor is 2.118. So this is how we can find the current through 6 ohm resistor by using Thevenin's theorem. Don't forget to check out the other videos on this channel. Also, if you want to buy my notes, then check the link in the description below. And thanks for watching.